Good afternoon, everyone. So in today's class, I just explained quickly about a variety cases of rolling motion on an inclined surface. So these cases are very useful and how to apply mechanics in different cases also we'll see. So I'll take case one. So this is a basic case one. All the concepts based on rolling motion I'm taking in today's class. So rolling motion on an inclined surface, right? So case one. Now taken inclined surface, making angle of inclination is theta. The given surface is a smooth surface and there is a cylindrical object. So this is a rigid body placed here and its mass is m. So mass of the object I'm taking here as m. Whenever you are taking mass of the object, so weight of course acts on the object only. So it is inclined plane, right? Object placed on the inclined surface. So resolve this weight into components first of all. So perpendicular to the inclined plane, mg cos theta is acting. Along the inclined plane, mg sin theta is acting. So I have resolved this force into components perpendicular mg cos theta and along the inclined plane mg sin theta. Now let us take a radius of this cylindrical object is capital R. Radius of the cylinder is R I have taken. Now this inclined plane applies some force that is called as a normal force because the object as well as the inclined surface both are in contact. So normal force acts here. As the surface is a smooth surface, what happens? So there is no friction force. Here I am writing frictional force F equals to 0 because the surface is perfectly smooth surface. Let us assume it's a perfectly smooth surface. Now, in the y direction, means vertical direction, with respect to the inclined plane, there is no acceleration. So n equals to mg cos theta. Total upward force equals to total downward force. This is the vertical direction with respect to inclined plane. Now, if you analyze along the inclined plane, how many forces are acting? Only one force is acting, that is nothing but mg sine theta. So according to Newton's equation, you can write F equals to ma. And now, here, what is the force acting on the object? That is nothing but a gravitational force, mg sine theta, right? Mg sine theta. And now, here, both are forces, only equate these two equations. So, ma equals to mg into sine theta. So, that implies a equals to g sine theta 25. So from this, what we can conclude is, irrespective of mass of the object, acceleration is a g sine theta. If you take a smaller mass or heavier mass, so acceleration depends on gravity and angle of inclination theta. That's it. So this is a very basic case, and the surface is smooth surface, cylinder is placed, and acceleration of the object is a equals to g sine theta. Now see, similar situation, but case two I will change the surface, or the case I will change first of all. This is case two. Just think here, case two. Now, same inclined surface only this one also. Case 2, I am taking same inclined surface I have taken. It's not perfectly straight. But so here also angle of inclination is theta. And same cylindrical object is placed. Same object only. And this is also a smooth surface. Right? But this time, this object is connected with help of a string to a support like this on the inclined plane. Now, mass of the object, and I will take different parameters here. Mass of the object is m. So we already know mass acting, mass of the object given means, so we can resolve this into components. So perpendicular to the incline is mg cos theta, along the incline mg sine theta, right? So mass is acting on the object, mass of the object is given due to that. So force I have resolved into components. Now here tension, so string is connected means, so tension force is also acting, so tension is T, right? So surface is smooth surface only. Now, if you think carefully here, acceleration of the object, can I say acceleration equals to 0 or not equals to 0? So it can be maybe anything. Acceleration may be equals to 0, it may not equals to 0 depending upon the tension T value as well as mg sine theta. So instead of assuming something, first of all proceed, analyze the situation, not solving the question only. First, take the situation and analyze it properly. So acceleration may be equals to 0, may not be equals to 0 depending upon the tension value and mg sine theta. Now, radius of this cylindrical object is capital R. So here driving force is mg sine theta, but it is passing through the center point, so it cannot create any torque here. But if you observe tension T, it is off center force. Off center force means the force which is not passing through the center is off center force. Due to tension force, so here object starts rotation, so that we can take angular acceleration is alpha. Right? Surface is smooth surface, so friction force equals to C. So instead of solving a question, instead of trying to get the solution for the given question, first understand the given situation, then analyze what are the parameters required. Then one by one write the equation. So finally we'll get the answer for that. Now here I am assuming mg sin theta is greater than tension T. So that what equation we can write is mg sin theta minus T equals to mj. So this is equation number 1. So here driving force is mg sin theta. That's why object is moving in the downward direction. But here tension is also acting, which is a off center force, means it can create a torque as shown. It is producing a clockwise torque. How can we say? So it's a clockwise torque. You can write the equation torque equals to R bar cross F bar. Use right hand thumb rule so that you can get here. So clockwise torque. Now I'm writing torque general formula, torque equals to I into alpha, right? But here torque is nothing but force into perpendicular distance. So force is nothing but tension T. And here perpendicular distance is nothing but the radius of the cylinder R. So T into R equals to moment of inertia of the cylinder is mr square by 2 into alpha. Here R values gets cancelled so that we can write. So T equals to m into R by 2 into alpha. So this is equation 2 can consider. But as the object is rotating, right here cylinder is rotating, that means we can relate angular acceleration as well as translation acceleration. So A equals to R into alpha. We know this equation. From this alpha value you can write alpha equals to A upon R. Just substitute here and cancel, you will get T value, so that you can substitute the T value here and simplify, you will get the value for acceleration. So here, this is the method you need to analyze instead of solving a question. First understand the situation and then so write the parameters and the equation so that you will get the answer for it. So this is case 2 and this is case 1. Now see case 3. I will take this time as a rough surface. First 2 cases I have taken only smooth surface. Now case 3. A bit fast also I'm explaining, should have some idea of this, then only will understand. This is not the first time I'm teaching, so it's a revision, quick revision, and the most important points, whatever the things required in mechanics, all I'm using at a time. So try to understand the concepts. Case 3. And now the surface is rough surface. So here theta is the angle again. And cylindrical object is placed like this. And one end is connected to a string to a rigid support on the inclined surface. But this time the surface is a rough surface. Surface is rough surface. Remember, so rough surface means immediately you have to think of friction force may be equals to 0 or it may not equals to 0. There is no rule that if the surface is a rough surface, a friction should present. No, it is a wrong concept. So friction may be present, may not be present. It depending upon the net external force on the object. So here mass of the object is m, so that resolve into components again. So one is mg cos theta and this one is mg sine theta. And here normal force acting on the object is n. So here also tension T is acting, tension force is T. As we know that the surface is a rough surface, now analyze carefully. Here what happens is the tension force is acting on the object. So it is off center force, just now we have discussed. So that tension wants to create here angular acceleration, that is alpha. Right, just observe that observe the cylindrical object here. So object wants to rotate in clockwise direction, means at the point of contact, it is sliding backward direction, right? The object is sliding backward direction. That means the friction should oppose this relative motion. That's why friction force is acting in the forward direction. I repeat this point, as the object is rotating clockwise direction, at the point of contact, sliding is backward. That's why friction wants to oppose the relative motion. So friction is acting in the forward direction. Now, here torque value can be equals to 0 or torque value cannot be equals to 0. That is why if you just blindly follow to get the solution of a given question, so may get wrong answers also. Here, even though off-center forces are acting, there is no rule that torque should be present. Torque may be 0. How torque may be 0? If tension force equals to frictional force, then net torque becomes 0, right? So even though there are off-center forces, there is no rule that torque should present. Torque may be 0. This is the point you need to keep in mind. Now here analyze the question taking the equation. So mg sine theta linear. First translation I am discussing. So mg sine theta driving force minus t minus f, because both are acting in the opposite direction, I have taken, which equals to m into a. This is equation number 1, right? So here three forces are acting on the object. Mg sine theta means in the horizontal I am discussing. So mg sine theta minus t minus f equals to ma. Now think with respect to the torque, rotational. Here two forces are acting, torque, tension force T and force is F. We can write tension T into R minus, so frictional force into R. Why I have taken negative sign here? Because the tension force is producing clockwise torque and the frictional force is producing anti-clockwise torque, right? So both are opposite directions. So negative sign I have taken. Torque equals to I into alpha. So I into alpha I have written. So T minus F into, take R as common, which equals to, again, moment of inertia of cylindrical object only. So mr square by 2 into alpha. Here also R value gets cancelled. So that T minus F equals to m into R by 2 into alpha. This is equation 2. Again, you can take the relation so that it is rotating also, so that angular acceleration and translation acceleration can relate. A equals to R into alpha. From this alpha value equals to A upon R. So you can substitute here and then simplify so that you will get the answer for the given questions. So this is the analysis we have to do whenever a given case is given. So take one by one and analyze the given situation properly. Now, one last question I discussed based on this. So there is the inclined plane given. So angle of inclination is theta, cylindrical object given here like this. And here object is tied with help of a string like this. So mass given as m and the radius of the cylindrical object is given as capital R. So the surface is a rough surface, right? It is a rough surface. Now here another thing also, if you observe this point carefully, frictional force is acting here in the forward direction on the object, right? Newton's third law also we need to keep in our mind that for every action there is equal and opposite reaction. Surface is applying on the object forward friction means object applies a friction force on the surface in the backward direction, right? So whenever you are writing about the friction force, keep in your mind that so friction is internal force, of course action reactions are positive. The next one here. So this is the given object having mass m, radius is r, connected with help of a string having tension force given as a T, right? Now resolve this into components. As the surface is a rough surface, so that the quotient of friction is mu. Now question is find the minimum value. Find the minimum value of quotient of friction, that is mu, so that object remains at rest. This is the question. Find the minimum value of quotient of friction mu so that the object remains at rest position. Nothing is there. First, instead of just going through the solution of the given question, first analyze the given situation. This is very important. Analysis is the most important thing. Now, is this the object? Let's resolve this into components. So mg cos theta acting in the perpendicular direction to the inclined plane, and mg sin theta is acting along the inclined plane. The normal force acting in the upward direction, this is N, and the tension force is T. Now here also, if you just consider that the object, this tension force tries to rotate in clockwise direction, this is alpha, right? So friction force is acting in the backward direction, this is the friction force F I have taken. But if condition is given, object is at rest means alpha equals to 0, acceleration is equals to 0. According to the condition given in the question, I have taken that angular acceleration is 0 because object is at rest position they are mentioning. And acceleration is also 0 as the object is at rest position. Now here also friction force acting on the object forward direction I have taken means on the surface friction force is a backward direction. Of course, friction force acting on the surface of the inclined is not required here, but keep that in your mind. Now write the equations here. Object is at rest position. That means driving force mg sine theta, opposing forces minus t minus f equals to ma. This is general equation, but here acceleration value is 0 as per the condition object is at rest position only. So acceleration is 0. So that we can write mg sine theta equals to t plus f, equation number 1. Here. And now rotational. Apply the condition for rotational motion. Here also, due to tension force, object wants to rotate in clockwise direction and the friction wants to rotate in anti-clockwise direction. But angular acceleration is 0 means torque produced by tension equals to torque produced by frictional force. So directly I am writing here PR minus FR equals to 0. Okay. So tension T equals to force is F. So equation number 2. Very basic points also I'm explaining, but a fast I'm going, you need to understand, you should have some basic idea of rolling motion, then only will understand, otherwise there is no use. So please learn the basic properly and then come and watch this lecture carefully. Then you will understand what is the importance of this, and each and every point is important here. Now substitute this t value in the actual equation here. Just substitute this value here. So mg sine theta minus, instead of t I can write f value minus f equals to 0. So mg sine theta equals to 2f. From this f value you can write f equals to half mg sine theta. So this is a friction value. But we know one thing, that maximum frictional value, how much you can write maximum frictional value or maximum static friction value is nothing but limiting friction, and its formula is mu into n. So F equals to mu into n is nothing but, if you observe the diagram here, normal force n equals to mg cos theta. So instead of n, write here mg cos theta. And another point, sometimes students are taking F equals to mu into n only. This is a wrong concept. Mu into n is the maximum value of static friction. If you take actual values, friction force may be equals to 0, less than or equal F, which is less than or equals to limiting friction. This is the right equation. Friction force may be equals to 0 or 0 is less than frictional force, and frictional force may be equals to limiting friction or less than limiting friction. So whenever frictional force equation you are writing, do not think F equals to mu into n always. That is a wrong concept. So friction value is in between 0 to limiting friction. Here. So this is the most important point here. But here, actually in the question they're asking for a minimum value for mu, so that we can equate these two equations, right? Just equate mu into mg cos theta, which equals to half into mg sine theta. Now here m values gets cancelled, g values gets cancelled. So mu equals to sine theta by 2 into cos theta. So which can be written as, final answer for this is 1 by 2 into sine upon cos is nothing but tan theta. So mu equals to half into tan theta. This is the answer for the given question. So again and again I am telling, instead of getting the answers or trying for the solution, so try to handle the given situation, understand the given situation properly, then only analyze. Otherwise, if you directly need to solve the question, so according to the your assumption you will follow and you won't get the proper answers. Here, so analyze the given situation properly so that the cases becomes very easy. Right. So watch this lecture carefully. Before that, once go through the basic points, then watch this lecture. I went a bit fast. This is a quick revision only. Clear? So take care, all of you. Bye bye. I'm ending this lecture, and the next class I will explain the remaining concepts. Bye bye.